So guys, we have a set of solved problems for you. The first question for you is, an electromagnetic wave of frequency f and wavelength lambda passes from vacuum into a dielectric medium with permittivity epsilon r equals 4.0. This is the relative permittivity, guys. Then find the resulting frequency and wavelength.
So to move on with this problem, first we use this formula that the velocity v equals to 1 by root over mu naught mu r epsilon naught epsilon r.
Right.
So I gave you this formula in the theory part. So this v, that is the velocity in the dielectric medium, is obviously equals to the frequency in the medium multiplied by the wavelength in the medium. That is, let us take as f dash and lambda dash.
Right.
So this is equals to 1 by root over 4.0. This 4.0 is for this epsilon r.
Right.
Since mu r is not given, let us assume it to be 1. And we know that mu naught and epsilon naught are just the normal like absolute permittivity and permeability of free space. So that gives rise to c. C is the velocity of light in free space. So this c is equals to f lambda, which are the frequency and wavelength that is given here. The resulting frequency and wavelength are these. So here we see that 1 by 4.0, which is under root, so this is equals to 1 by 2. So one thing to keep in mind here is that the frequency is due to the source of the wave, the electromagnetic wave. The frequency is not affected by any change in the medium. The medium might change the wavelength, but the frequency is an intrinsic property of the wave, that is because of the source. Let us say if this is a source and this is vibrating at a frequency f, so when the wave will travel, it will always retain this frequency f. So this
irrespective
will not
of the
change.
medium.
Yeah, it is independent of the medium. So this f will always remain f. So whatever changes there, it will be in this lambda. So here lambda dash would be equals to half of the original lambda. So this is the resulting wavelength, that is resulting wavelength lambda dash equals to half of lambda, but the frequency would remain the original frequency, that is f. So here you have your final answer, lambda dash equals half lambda and frequency f dash equals to f, which is the original frequency.
Okay, so that's one important information, guys. The frequency of a wave is only dependent on the source. It doesn't depend on what medium it's traveling through. Now let's have a look at the second question. A radio wave has a maximum magnetic field induction of 10 to the power minus 4 Tesla on arrival at a receiving antenna. What is the maximum electrical field intensity of such a wave?
Okay, so for this problem, we are going to use this formula. E naught by B naught equals to C. C is the speed of light, that is also the speed of any electromagnetic wave, let alone radio waves and microwaves, whatever be the case. Here we have E naught, which is the amplitude of the electric field, and B naught is the amplitude of the magnetic field. So here we can say that E naught equals to C B naught. So here we are sure of the speed of light, that is 3 into 10 raised to the power 8, and B naught has been given, it's given to be 10 raised to the power minus 4. So here it's a basic multiplication and you get the answer 3 into 10 raised to the power 4 volts per meter. So this is the amplitude, that is of the electric field. So this is the intensity of the electric field.
Right. So guys, you can make a note of this also. Whenever you are asked to find maximum magnetic or electric field, it directly implies the amplitude of the
because whenever you have a wave, the maximum is the amplitude. This would be the maximum. So if this is a sine wave, the maximum would always be the amplitude, whether it be the electric field, magnetic field, or the wave itself. The maximum is always the amplitude.
Exactly. So we'll move on to the next question now. In a plane electromagnetic wave, The electric field oscillates sinusoidally at a frequency of 2 into 10 to the power 10 Hz and an amplitude of 48 volts per meter. What is its wavelength?
Okay, for this we do not actually require this amplitude, because here we have been given the frequency and we are asked to find the wavelength, and it's
Right.
a sine wave which oscillates sinusoidally, and the frequency is given. So we have a ready-made formula, lambda equals to c by nu. So here it is equal to 3 into 10 raised to the power 8. This is the speed of light or any electromagnetic wave in free space, divided by 2 into 10 raised to the power 10, which is the frequency given.
Right.
So we are sure of the wavelength. It comes out to be 1.5 into 10 raised to the power minus 2 meters. So here this was a fairly easy question, but you should not apply the sine equations for this kind of problem, because the amplitude is not really required. You might think about using it like this, E naught sine kx minus omega t, all that stuff.
Right.
This will be the amplitude, but here you are not required to do all that. You have the ready-made formula for this, lambda. So just use the frequency, and this is an electromagnetic wave, so the speed is known. So this will give you the wavelength. Since there is no other thing mentioned, like any medium it's traveling through, so the speed would be 3 into 10 raised to the power 8. So you can just assume this. So for
Correct.
this you get the final answer as 1.5 into 10 raised to the power minus 2 meters.
Right. Okay guys, it's time for us to move to the next question. What is the amplitude of electric field in a parallel beam of light of intensity 4 watt per meter square?
Okay, so this question is also formula based, as is the case with almost all the problems that are from this chapter. Most of them are like formula based or are related to some simple concept.
Right.
So to solve this problem, let us write the formula. I equals to half of epsilon naught E naught square C. This was a formula for the intensity related to the epsilon naught, E naught and C.
Right.
So here we know C, and we need to find this E naught value. Epsilon naught is also a constant, and so we can simply do the calculation because I has been given. So that is E naught equals to root over twice I by epsilon naught C. By simply doing some simplifications in this equation, we get this, and we substitute the values as 2 into 4 is this intensity,
Right.
divided by epsilon naught is 8.85 into 10 raised to the power minus 12. This is a constant and you are supposed to remember this, and multiplied by the speed of light, 3 into 10 raised to the power 8. So after doing all the calculations, it comes out to be 55.5 newtons per coulomb. This is the unit of the amplitude of the electric field. So this is our final answer, which has been asked in this question.
So another simple question. We'll move to the next question now. Question number 5. Given the wave function in SI units, that is, for a wave to be 10 to the power 3 sine pi 3 into 10 to the power 6 x minus 9 into 10 to the power 14 t, what is the speed of the wave?
Okay, so here we have been given the wave function in SI units. This SI units thing is very important, because otherwise you would not know what the units are, and you cannot come with a final answer. So here we just write this equation of the wave equals to 10 raised to the power 3 sine pi, and we bring out this 3 into 10 raised to the power 6. Like we have this 3 into 10 raised to the power 6. This is multiplied by x minus 3 into 10 raised to the power 8 t.
Right.
So this thing we can have as an extra. So here it is 10 raised to the power 3 sine 3 into 10 raised to the power 6 pi, and x minus 3 into 10 raised to the power 8 t. So you also should remember the basic form of a wave equation, which you learned in your waves and oscillations chapter. So that is, this is equals to a sine of twice pi by lambda x minus ct. So it is basically a is the amplitude, lambda is the wavelength, and you have c as the speed of this wave.
Right.
So here just do a basic comparison. This thing sine would come here, this 10 raised to power 3 is this, x is x here, t is still t, and what you have this as the velocity. So this is the speed, 3 into 10 raised to power 8. C equals to 3 into 10 raised to power 8. Since it is in SI units, it's meter per second, which is our required answer for the speed of the wave.
Correct. So you have to remember to convert it into the basic form of a sine 2 pi by lambda x minus ct. Now we'll move on to the next question. Now the question number 6 says a capacitor having a capacitance of 2 picofarads has an electric field changing across it with a value of 10 to the power 12 volt per second. What is the displacement current?
So this is a question that you might have come across in your electricity chapters, but since this is related to this chapter, I am just going to give you a brief revision of this question in this chapter also. So for this we have a ready-made formula, that is I d, which is the displacement current, equals to dq by dt, which is true for all capacitors. So this is equal to dCV. Since you have done this in electrostatics chapters, CV is equals to Q, C is the capacitance, V is the voltage,
Right.
divide by dt. Since C is a constant here, that is 2 picofarads, so we bring it out and it is dV by dt. So
Right.
this is fairly simple because C has been given as 2 into 10 raised to power minus 12. Due to the pico factor here, it is 10 raised to power minus 12 multiplied by this is given to be 10 raised to power 12 volt per second, the
Right.
electric field changing across it. So it is 10 raised to power 12. So these two values directly go cancelled and it is 2 amperes, which is the required displacement current.
Right. So it's time for us to move on to the next question. An electromagnetic wave going through vacuum is described by E equals E naught sine kx minus omega t and B equals B naught sine kx minus omega t. Which of the following is true?
So we have been given 4 options and we have to select one of these. So how do you think we'll approach this problem? For this, you need to remember a few things from the wave and oscillation chapter about this k and omega. So we have twice pi by lambda equals to k, where lambda is the wavelength, and we have twice pi f equals to omega, here f is the frequency. So
Right.
these are the basic relations of this omega and k being related to the wavelength and the frequency of the wave. So we have lambda equals to twice pi by k, and we have f equals to omega by twice pi. So here we know that the speed of light is, or of any electromagnetic wave, is equals to lambda into f, that is the wavelength multiplied by the frequency, which from these it comes out to be omega by k equals c. So doing some simplifications by substituting value of lambda and f, we get omega by k, which is equals to the speed of light. So this speed of light is also equal to E naught by B naught.
Correct.
From the equations relating the speed of light to the amplitude of the electric and magnetic fields related to the electromagnetic wave. So with this we can see that B naught omega equals to E naught k, which is option A. So I'm also going to tell you an alternate procedure for this. You can also do this by going through dimensional analysis. In dimensional analysis, this is pretty easy because E naught by B naught, as you all know, it has meter per second because it gives the speed of light, and you have k, which is in meter inverse, and omega, which is in second inverse. So simply if you do the divisions, that is omega by k also comes to be meter per second. None of the other relations would come in this. And in such problems, if you are confused as to what to do and how to proceed, dimensional analysis is also a powerful weapon, because you have the options given and you can do the dimensional analysis and come to the result, because both of these are in meter per second, that is like length time inverse, that is the dimension. So you can simply use this also, because the options have been given. This is an easy way to solve this problem.
In fact, even if you can't find the right answer using the dimensional analysis, you can at least eliminate the incorrect answers.
Yeah,
right?
you can eliminate the incorrect ones. Here, since this none of these is also there, so it is a bit difficult. But if all the answers are given in terms of like E naught, B naught, K and omega, so you can eliminate almost like 3 of them and you will be left with the right answer. So dimensional analysis can be used as a powerful tool in many questions. Not only this, there are many other places where you can use this and make your problem easier.
Right. So guys, this was another fairly simple question. The question number 8 says the transverse displacement y of x comma t of a wave on a string is given by y equals e to the power minus iota ax square plus bt square plus 2 root ab into xt. You have to find the wave velocity and direction of propagation.
Okay, for this we have y, which is the given wave equation for a wave on a string.
Right.
So for this we have y equals e powers minus I ax square plus bt square plus 2 root of ab into xt. So basically we can convert this into e powers minus I root a into x plus root b into t whole square.
Correct.
So this is one fairly simple equation. So here it is a function of the type y equals to, it's a function of kx plus omega t type.
Right.
So here we have a lot of operations and all that, but still in the end of the day it is a function of the type k and omega. K is related to x, here k can be replaced by root a, and this omega is this root b.
Right.
So here what we have is, it is a function of kx plus omega t type, and we all know that omega by k gives the speed of the wave.
Right.
We also saw this in the previous problem. Omega by k equals the speed. So just substitute the values and we have the speed as root over b by a. So what do we do about the direction? So you should know that if this is the case, it is k is related to x, so it is a wave in the x direction.
Right.
This is kx, if there is x here, so this is a wave propagating in the x direction.
Right.
So from this equation itself we can find out the direction as well as the speed of the wave.
Okay. So basically if you can denote a wave function in form of a function of kx plus omega t.
Yeah, so we do not have to like simplify it to make it a linear function or anything.
Right.
We just need to have it as a function of kx plus omega t, and since it is a wave, it has been given, so we know that this is an oscillating function. So we just have to find out the speed and the direction.
This seems big. The sun delivers 10 to the power minus 3 watt per meter square of electromagnetic flux to the earth's surface, which is at a distance of 1.5 into 10 to the power 11 meters from the sun. If the whole incident electromagnetic flux is absorbed by the earth, then answer the following questions. Now you have 4 different questions here. First, we'll go one by one now. What is the total electromagnetic power of sun falling on the earth? Ankur.
Yeah, okay. So for this first part of this problem, we have been given the radius of the earth as 6400 kilometers.
Right.
And since the flux is also given, so we have the power, total power of the electromagnetic flux that the earth absorbs is equal to the flux multiplied by the total area. This will give us the power. So
Correct.
for this we have the flux is been given as 10 raised to power 3, and the area of the earth is, we are considering earth to be a sphere, although it is not a perfect sphere. So it is 6.4 into 10 raised to power 6. This is in meters. Here it has been given in kilometers.
Right.
So this is the area of the earth, and we get the final value as nearly 5.1 into 10 raised to the power 17 watts, which is the power absorbed by the earth from the flux of the sun, like the flux of the electromagnetic waves falling on the earth from the sun.
Right.
So this is the answer to the first part. This is
So
A.
the B part says, what is the total electromagnetic power of the sun?
Yeah, total electromagnetic power of the sun is given by, if this is the sun, we'll consider the sun at the center, and this would be the sphere where we know the flux at a distance of 1.5 into 10 raised to power 11 meters. So this is a sphere with a radius of 1.5 into 10 raised to power 11 meters.
Right.
So we have been given the flux, and as we all know, flux into area gives the total power.
Right.
So instead of considering the area of the earth, now we consider the area of the virtual sphere, which has the sun at its center, and the radius would be 1.5 into 10 raised to power 11, because this is the distance at which the flux is given to be this.
Right.
So here what we do is we simply do the same type of calculations again, and
Right.
we get it 10 to the power 3 into 4 pi 1.5 into 10 raised to the power 11 whole square, which comes out to be 5.6 into 10 raised to the power 26 watts.
Right.
So this is the total electromagnetic power of the sun. So with this we have solved part B.
Okay. So the C part asks us about the total electromagnetic power that is incident on a roof of dimensions. The area is given 8 meter into 10 meter on the surface of the earth.
So this is a similar question to the first part. Again we have the flux and we have the area. So again we do the multiplication for the power on the roof equals to the flux that has been given. It is 10 raised to the power 3 multiplied by 8 into 10, which is the area of the roof on the surface of the earth. So instead of the surface of the entire earth, we are just given a part of it, that is 8 into 10 meters. So here the answer is 8 into 10 raised to the power 4 watts, which is the power on the surface of this roof.
Right. Now the final part asks us about the same roof. What is the radiation force on the roof?
Okay, the radiation force, it can be found out after finding the radiation pressure on the roof. So for radiation pressure we have a direct formula, which is, this is pressure, mind you, not power. So for this it's equal to the I by C. I is the flux or the intensity, whatever you may like to say. So with this we multiply for the force equals to area into this pressure. So we have the area as this. So I into area is the power,
Right.
divide by C. Power on the roof, that can be denoted as PR, which we already found here. So it is 8 into 10 raised to the power 4 divided by the speed of light, that is 3 into 10 raised to the power 8. So after doing the calculation, we get the final answer as 2.67 into 10 raised to the power minus 4 Newton, which is the force radiation due to the electromagnetic radiation incident on the roof.
Okay. So guys, this brings us to the end of the problem set. Now the chapter might seem simple, but you need to keep practicing and you need to remember a lot of formulas to be able to solve a lot of problems, and you have to take care of the SI units or the units maybe. But yeah, one thing, keep practicing.